Yes, it was Quincy.
Hey, all right. Yes, Jill remembers. There we go. Hi, Jill. I hope you're doing well. Okay. So let's talk about the next topic, which is we've moved from basic descriptive statistics, and we're now moving to histograms, skew, and kurtosis, right? And so let's just give a slight amount of background here. We'll do some coding first. I mean, in a minute, but like when you talk about these concepts like skew and kurtosis, or even like descriptive statistics to a certain extent, oftentimes the reason why we talk about these things is because when you're doing data science for real, like when you're running actual academic publications, this is something we do in my lab all the time, right? Like we write academic papers, we run a study, and we wouldn't bother to run the study if we knew what the answer was, right? We don't know the answer going in, and oftentimes we want to find out what that is. And the catch is some of these kind of descriptive or algorithmic approaches to looking at the data, they can provide us clues as to whether or not we screwed something up. In other words, they help us determine whether or not there's a mistake in our data, right? In other words, oftentimes in data science, we don't want to fool ourselves. And skew and kurtosis do not provide us everything that we need to know. But oftentimes the approach of using a histogram and then looking at skew and kurtosis are very helpful techniques for starting that process. So just to give you some perspective, when I teach programming at the PhD level, oftentimes we do lots of exercises where students look at examples of various kinds of skewness and various kinds of kurtosis, and we ask ourselves, how would they impact particular kinds of statistical tests that you might run for an academic publication? We'll talk about that very briefly. I won't bore you with all the mathy goodness, but I want to give you just kind of the sense of it because it's an important topic that students should at least know at the conceptual level. So I'm going to pull up the tutorial, and I'm going to do this one mostly through Quorum, through the website, because I think it's okay. And we're going to generate it through the website. So if you want to do this in Quorum Studio, you can download the data set and follow it along, and that's okay. There's an Airbnb New York City data set if you want to look at that one in particular. But so just like any of these charts, you do stuff the same way. So like you have, you call histogram in the code, and let's maybe do that first and kind of go line by line just to make sure that you have that, and then let's jump back up and kind of look at some of the equations and try to not melt our brains for a minute. So in order to use histogram, we're still going to use our data frame. Oh, you know what? I'm going to pour this in Slack. That's the example that I'm looking at.
Looks like this one's different than the tutorial.
It is. They made them different than the tutorial. So, and I think that they did that to show right and left skew and the different kurtosis values, if I recall correctly. So I think Christine changed that, if I recall. So, okay, so you've got the data frame, and then you've got this use statement related to histograms, which is at a particular location. Nothing new there. You've got a data frame, and then you're loading a particular data set, which is, oh, that's what you meant, Hannah.
Yeah.
Number of children is not the Airbnb data set. Well, that's confusing. Can you mark that down so that they know to unify it so that it's looking at the right thing?
The Airbnb one is the one used in the actual tutorial.
Yeah, but then it's not. Okay, that's confusing. Yeah, we should change that.
When you click on the link to download it, it opens it directly.
Yeah, well, and what Hannah is pointing out, and I didn't quite realize this now that I'm looking again, the data set in the Skew examples, I had asked them to, oh, it is listed. Okay, there's this number of children CSV. Let's pull this up. First name, last name, number of children. It must be some kind of spurious correlation chart or something like that. Or something like that. There's two CSVs here. One is number of children, one is called exam scores CSV. I have a hunch that what was happening is that they were trying to show examples of various kinds of skew and kurtosis, and they had to look for some data sets that where that was the case. I could be wrong about that, but that's my suspicion. Then there's some exam scores, and it looks like you've got males, females, and then certain kinds of degrees, and then some scores. In any case, for our purposes, the actual data set doesn't really matter that much because we're talking about skew and kurtosis and histograms. So the point is, I make my data frame, I then load it in, frame colon load, and then the data set. I say what my selected columns are, just like I've done for all the other charts. And then I say histogram chart equals frame colon histogram, and this makes the actual histogram. Now we can talk about that more in a little bit, but what I want to do is I want to run it, and I'm going to pull it up in a screen reader just like we have been before. So I'm going to flip that on real quick. Oh shoot, but I didn't have the share screen with the sound. There we go. Nope, that is not what I intended at all. Okay, so I'm going to press Control R, or you can navigate to the button. And I forgot to turn the screen.
Voiceover on Safari.
Okay. And so you'll notice that if visually on the right-hand side, it pulled up a histogram.
Enter game button. You are currently on a button. To click this button, press Control Option Game Web Dialog. Number of children for arbitrary families. Histogram with 22 bars. Use the arrow keys to navigate chart information and tab to access the chart content web application. You are currently.
That's interesting. It says 22 bars. I only see 1, 2, 3, 4, 5, 6. Hannah, what am I doing wrong here? Why is there only 6 when it's 22? Is that a bug?
I guess so. Yeah.
Huh. Okay, we better mark that. So if I press tab.
Number of children for arbitrary families. Histogram with 22 bars. Use the arrow keys to navigate chart information and tab to access the chart content. Number of children, 0 to 1 bar, 37, 1 of 10 bars. To navigate the list of bars, use the arrow keys to move.
Now it says 1 of 10, but there still isn't 10. 1, 2, 3, 4, 5, 6. That's got to be a bug. Don't forget, these libraries are really new.
So I think because histograms go based off of bin widths and they set like the maximum, right? It has to count it as a bar even though it's 0.
That makes sense. So that would be 10. 10
Yeah.
is the right answer.
Yeah.
Okay. So yes. Okay. So the bug is in the chart info above it, I think then, right? Because that said 22 bars. It would be 10.
It must be getting something from somewhere.
Yeah. Well, anyway, we should tell Tim because I know he managed those settings. So anyway, so you'll notice that when you navigate in a histogram, it does it slightly differently. So you'll notice that visually there's 1, 2, 3, 4, 5, 6 bins that have information in them. In a histogram, it's sort of like asking, you know, how many are at 6? How many are at 5? How many are at 4? That sort of idea. And so if I navigate them.
Number of children, 1 to 2 bar, 29, 2 of 10 bars. Web app number of children, 5 to 6 bar, 38, 6 of 10 bars. Web application. You are currently on a web application.
You'll notice that I can go through all those bars, but I can also go to the next one.
Number of children, 6 to 7 bar, 0, 7 of 10 bars. Web application.
But I can also navigate through any of the chunks where there isn't anything there. When you think about it, that makes sense. Because a person that's going to need to explore a histogram is going to have to be able to tell where are the regions of my data blank and where are they not.
number of children 7 to 8 bar, number of children 8 to number of children 9 to 10 bar, 0, 10 of 10 bars. Web application.
Okay, you get me so far? The idea in histogram is that you're binning things so that you have a sense of, in a data set, where is everything clumped, right? And so because of that, in order to know where those clumps are and where they're not, when you traverse them, you actually don't just traverse the bars. You also traverse the blank spots in the chart. And that gives you information that you would get visually, but that you wouldn't get from a screen reader if you just had like an alternate description or something like that. There's no way you could get that level of detail from an alt, more or less. Okay, questions so far? Are we good so far? See some thumbs up.
Voiceover off.
Okay, so now a lot of the other details of histogram are essentially the same as what we've done before. So I think we've talked about the title. We may not have done the font size, title font size, but you can make that bigger or smaller. On my current screen, it actually kind of cuts it off at that particular dimensions. So if I pull it out, it's a little bit better. But that's partly because of the web interface, just the way that it handles all its stuff. But you can change the font sizes. You can set the titles for the axis and the y-axis. You can set the legend title. You can set the subtitle, which apparently is age ranges of dog breeds, which is actually not correct at all. So yes, our documentation is 170 pages, but imperfect, right? So Hannah, do you mind marking that one down too for the
yeah,
student?
I'll mark it down.
Thank you. We have our color palette. In this case, we set it to one called trustworthy. And then we get to this thing that says tick interval. What do people think tick interval is? That one's maybe not quite as obvious.
The tick marks, the distance between the tick marks on the graph.
Yeah, so this gets a little hairy because sometimes some of these things are purely visual, but we still want you to be able to adjust them if you want to. So for example, I set the tick interval now to 2. Oops, and then I spilled my coffee on myself. If I do that, watch what happens to the chart accessibility-wise.
Voiceover on Safari. Histograms, Skew, and Kurtosis window. Edit text. Use libraries.compute.statistics. Enter game button. You are currently on a button. Game web dialog. Number of children for arbitrary families. Histogram with 17 bars. Use number of children for arbitrary families. Histogram with 17 bars. Use the arrow keys to navigate chart. Number of children 0 to 2 bar, 66, 1 of 5 bars. To navigate the list of bars, use the arrow keys to move between bars in list order. Use.
Okay, so ignoring the fact that there's a bug in the chart info that says that there's 17 bars when there actually isn't, which it clearly we'll have to fix, and that's okay. You'll notice that when I set the X tick interval, it actually does something else. There's now 5 positions as opposed to 10, which means it's now putting in the bars things that are clumping together.
Mine.face to everyone. Share to
Ah,
set mine to 0.5 for the tick marks.
Zoom.
Now there are half children.
It's funny, Zoom on Mac, I'm not sure if it does this on PC, but Zoom on Mac when you're using VoiceOver is infuriating, in part because it self-voices the stupid comments instead of sending it through the normal. Anyway, many of you probably understand this. So you get 2 voices at the same time. This is not a feature that we coded, right? Just for the record. In any case,
Safari. Histogram.
inside of these bins, we now have 5 of them instead of 10.
Number of children 6 to 8 bar, 0, 4 or 5 bar. Number of children 8 to 10 bar, 0.
And doing it like this, allowing you to set these tick intervals in a way that allows you to adjust things like the bin, allows you to, at the end of the day, explore your data in different ways. That's kind of the point.
Voiceover off.
Make a chart, adjust the bins, and do the stuff like that, and then either re-look at it or reanalyze it with a screen reader so that you can get a sense of what's there. Now there are half children. That's right, Mike. There are half children. Okay. So let's take a look at a couple examples that have different kinds of skew. So I'm going to go down to the bottom example. So the next example, which is a left skew in theory. And I'm going to post it in. And if I run this thing, okay, perfect. I want to do two things. Number one is I want to look at it and describe it, but then I also want to kind of traverse it through a screen reader as well, so you can get a sense of like what it feels like with both modalities. So visually, it's slightly unintuitive, but a left skew means the kind of fat tail is on the right-hand side. And a right skew is the fat tail is on the left. I mean, not tail, the fat chunk is on the left-hand side. So this really is a left skew. And you'll notice visually as well, it's not perfect. In data science, there's always this like temptation from people that are just learning. Oftentimes I see this with my own students, even at the doctorate level, that a data set has to be perfect. And the reality is that like that just doesn't happen. When you're using real data sets, they're going to be messy. Like it's just the nature of gathering data. That's just the way it is. So if I want to hear a left skew, if I'm going to pull up the screen reader.
Voiceover on Safari. Enter game button. Game. Web dialog. Number of children. Number. Math score.
Okay. You'll notice that when you have a left skew, oftentimes when you're going from left to right, you're going to hear a lot of zeros.
Math score 5 to 10 bar 0 2 of 20. Math score 10 to 15 bar 0. Math score 15 to 20 bar 0 4. Math score 20 to 25 bar. Math score 25 to 30.
Hey, Hannah, can we also change that to not say math score right at the beginning? That would be good. I think the auditory cue should probably give the bin height first, but we'll have to think about that. We should ask people that in the focus group, in the informal one.
Math score 30 to 35 bar 2 7 of math score 35 to 40 bar 4 8 of 21 bars. Math score 40 to 45 bar 4 not math score 45 to 50 bar 5 10 of 21 bars. Math score 50 to 55 bar 9 11 of 21 bars. Math score 60 to 65 bar 7 13. Math score 70 to 75 bar 15 15.
I won't go through all of it, but the point is that like if you go through these, you can kind of hear that the numbers are going up and then they'll go down again, and they kind of seem imperfect, right? Now, I do think that there are some other things that we might be able to do better here. It might be that like using some sonification or something like that would actually make this a little bit easier to understand. And we haven't really experimented with any of that, although there's some really good groups like called the Graphics Accelerator. Apple has a couple of experimental things that they're working on. And there is some interesting stuff going on in that space, but nonetheless, as at the moment,
Voiceover off.
Stefik, if I can have for a quick second. So this one was left or right skewed with all the zeros in the beginning, please.
That is a left skew.
Thank you.
Yep, a left skew. It's counterintuitive, but if all the big junky stuff is on the right, that's a left skew. If all the big junky stuff is on the left, that's a right skew. Because it's indicating where the tail is. And so the tail is the kind of like mole or blank spot. Does that make sense? It feels backwards to me that like,
It does feel backward, but now that you explained it, I understand, I think. Thank you.
Yep, no problem.
And in this, so it was counting the zero, the places that had 0 as values as individual bars, correct?
Yes.
Okay.
And it's doing that with histograms on purpose, because in histograms, what we're trying to learn is where's the data clumped. And so with a bar chart, your goal is to figure out what's the data at each bar point. With a histogram, that's not the goal. The goal for a histogram is to figure out where do things exist and where are there blanks. So what the team did was they made it so all the positions where you could have data are available. And so it's up to you to traverse them and figure out where all the blank spots are. It's the only way you could really explore the graph to find out the information that a histogram wants you to provide. That makes sense.
Yeah, that does make sense, because in this case, a 0 value is information that you need, whereas in a bar chart, you're looking at different information.
Exactly.
Okay.
So it's sort of like with all these charts, what we tried to do from an accessibility perspective is not ask ourselves, how do we get access to the visual content? That's not really the question we asked. What we asked instead was, what is it trying to explain? And then we wanted to make it so that when you had access to the chart, you could get the same explanation through a screen reader or AT device that you would by scanning it visually. Or at least that was our intent. You know, that doesn't mean we're perfect, but
Oh,
like that was
awesome.
sort of our intent. Yeah. I don't know. Does that make any sense, or do you think that's
Yeah,
right?
no, I think that's awesome.
Yeah. Okay, cool. Okay, so there's a left skew. Okay. Now let's take a look at kurtosis. And skew is really talking about the, you know, how kind of like, what's the word I'm looking for? Like symmetrical. Skew is really talking about how symmetrical your data is. So it can be left or right skewed because it's not quite symmetrical, right? Kurtosis is kind of one way people describe it. It's not exactly right, but it's pretty close. We often think of kurtosis as being kind of like fat or skinny, right? And so if I pull up a chart with high kurtosis, visually what we see, and I'll explain how you can detect this with a screen reader too. Visually what we see is that there's a lot of data kind of in the middle of the chart, and it's quite high, whereas, and then it kind of exponentially declines very quickly. I'll say that again. You've kind of got some points in the middle that are quite large, or quite high. They've been high, and then they exponentially decline very quickly. Now, let me ask a conceptual question that might lead to some discussion before I get into the actual screen reader part. Why on earth would anybody care? Why does it matter? Like the skew, kurtosis, why do people even care about this stuff? Like, why would high kurtosis, for example, screw up a statistical test? Why could that even be? It's not
It doesn't show a sample range that you want.
That's a good guess. Any other guesses? Have I lost everybody? I'm talking about math now, so people are like, oh, man.
And I think kurtosis sounds like, you know, a terrible disease.
Yeah, it does, doesn't it? So here's the deal. When I go up and I look at equations for statistics, they often have two things, right? They often have a numerator and a denominator, right? And it turns out that a lot of the statistical tests, the stuff that happens in the denominator, if you have high kurtosis, kind of gets closer and closer to zero. So what happens as something gets closer and closer to zero if it's in the denominator? If you all remember,
larger and larger.
It kind of gets bigger and bigger. And so part of the problem is that when you have high kurtosis, if it gets closer and closer to zero, it kind of makes the statistical tests wonky. I think wonky is a good word without trying to get too much into the weeds of the math. Now, obviously, I'm grossly oversimplifying. Like when you have statistical tests, they have various kinds of techniques. They use all sorts of complex formula. This is not a universal truth, nor should it be pretended to be. But nonetheless, the point is that high kurtosis messes with the math. And it's only a problem if it's really bad, right? Statistical tests are actually very robust to deviations in normality, very robust to deviations in skewness. But when they get really bad, then they don't give you any useful information. So you can imagine if you had all of your data points in one single spot, you're not going to get much out of that, right? From a statistical testing perspective. So, and similarly, if your data was all completely flat, well, then that's going to mess stuff up too for a different perspective. So high kurtosis is like everything is kind of like really tall and skinny. That's kind of what high kurtosis is. Okay, so let's look at this in a screen reader.
Voiceover on Safari.
Okay, now if I navigate,
Enter game button.
I navigate and I click when I'm online, don't forget that there's this magical button that I have to jump into. And that might sound from a screen reader perspective like an extra step, but actually it's important because you can always traverse, it removes the focus trap. So you can always go away from it and back to it. So that's why it's there. So if I press enter on it.
Game, web dialog, iris classification, histogram with 73 bars. Use the arrow keys to navigate chart information and tab to access the chart.
Still has the accidental bar mistake, so we'll fix that. But the if I then traverse,
iris classification, Siebel with CM 0.
I'm going to hear a lot of zeros right at the beginning. I do wonder, maybe we should have the 0 be the first cue. But anyway, for histogram.
Siebel with CM 0.2 to 0.4 bar 0, 2 of 30 bars. Siebel with CM 1.2 to 1.4 bar 0, 7 of 30 bars. Web application.
Yeah, I wonder, Hannah, I wonder if we should actually just, when you navigate across, if it says 0, 0, 0, 0, 12, 15, 19, and then it has the other stuff later in the auditory cue. That might be a better cue.
All right, so like, yeah, the value, then the range, then the name.
Possibly, maybe.
That sounds good.
We'll have to ask people, but still. So if I keep going.
Siebel with CM 2.0 to 2.2 bar 1, 11 of 30 bars. Siebel with CM 2.2 to 2.4 bar 10, 12 of 30 bars.
So you'll notice that the value jumped from 1 to 10 very quickly. So that's a 10-fold difference.
Siebel with CM 2.4 to 2.6 bar 8, 13 of 30 bars. Siebel with CM 2.6 to 2.8 bar 28, 14 of.
Now it jumped to 28. So within only a few bins, it jumped from 1 or 2 or 0 to 28. That's a very large jump.
Siebel with CM 2.8 to 3.0 bar 10, 15 of 30.
It then jumped back to 10.
Siebel with CM 3.0 to 3.2 bar 38, 16 of 30 bars. Siebel with CM 3.2 to 3.4 bar 19, 17 of 30.
19, 18,
Siebel
12,
Siebel
2, 2, 1, 1. And then
Siebel with CM.
All zeros from there on out. So the moral of the story here is, if you're listening to if you're looking at the chart, you see that there's this big clumpy spot in the middle, and that's high kurtosis. If you're using a screen reader, you have to traverse it, but you think about the numbers and how they're changing and the speed at which they're changing, and that's how you can figure out high kurtosis. There's probably
Voiceover off.
I do wonder whether stuff like sonification might be helpful here, but nonetheless, that's the idea of high kurtosis. Questions? I can do low kurtosis next, but any questions? All right. I'm not sure if that's good or bad, so let's just do one more. This is low kurtosis. Okay, now with low kurtosis, on the right-hand side, visually what we observe is that the data doesn't really have, well, actually, this data is a little funny. So the interesting thing about data sets is that it's almost never the case that you have something that's super, super clean. Like, it's really easy to like look at a textbook and find the nice little curve where they showed you exactly how low kurtosis is supposed to look like. But the reality is that, oh, we should totally calculate kurtosis here too. We'll do that. Okay. The reality is that for these data sets, sometimes things look a little messy. So I'm going to describe this, and that is that it sort of goes up for a little while, and then it kind of goes down for a little while. And then it goes up a little more, and then down back to the bottom. And then on the very right-hand side, it kind of goes up the highest, and then it kind of drops back down a little bit. And so this probably is a reasonable example, although it's messy, of lower kurtosis. And so maybe what we should do then is let's go ahead and calculate it out so that we can kind of see what that kurtosis is. So in order to do that, let's jump back to Quorum Studio. Let's take one of these examples. Let's take this low kurtosis example, and then let's put this into Quorum Studio. So first I'm going to get the data set. And I'll put the direct link into the, that's not it. That's definitely not it either. Oh, wait, that was a download. Okay, cool. This one's big. I'm going to put the data set directly into Slack so people have it. Okay, and this is cars1.csv. And I'm actually just going to put this into the folder that I had before. Which was my Derek Likes Dry Beans application. And I'm going to go back to Quorum Studio and I'm going to change the name to the one that I have. But before I do that, I want to look at the data set really quick for this one because it's going to point out something again closer to real data. So I'm going to pull this up and I want people to notice that this file is 1.3 megabytes, right? And so this gets closer to one of the things that we tried to do on some of these examples. This gets closer to highlighting why we often want programmatic ways of handling data, not just messing with a spreadsheet. Because if I look at this data set and I'm scrolling through it, 1.3 megabytes is a lot. Still scrolling. So if I go down to the bottom, it's about 5,077 rows from different kinds of cars and stuff like that. And there's columns A through R. So there's quite a bit of data in this file. It's 1.3 megs on disk. So the first thing that I'm going to do is I'm going to try to replicate this code. And so I'm going to take the example from online, the Skew and Kurtosis example. Oh, where'd it go?
Oops.
Yep, where is it? I'm going to copy it into Slack so people have it. So if you don't want to go hunting, you don't have to. And then I'm just actually going to copy it in, and I'm going to change the file name so that it removes that data folder or wherever you put it. And I'm going to run my code just to make sure that I get the same answer. Oops, not screenshot, share screen. And I get the same chart. So attributes of EV cars with my histogram. Okay, now I want to give you a minute just to make sure that everybody can get to that point. So go ahead and toss it in Quorum Studio. And feel free to download it from the site or from Slack. I grab you. Give you just another 1 minute to do that. All right, is everybody ready?
Got it. Yeah.
Okay. All right. Okay, so the first thing that I want you to do is I want you to go ahead and calculate kurtosis of your data set. Now, how do you do that? Well, there's a couple ways to do it. The first one, and you're all going to like this option. This is perfect. This is exactly what you should do. Is you should go to the equation for kurtosis right here, and then hand code all that really quickly, right? That's option one. Okay, so just to remind you, it's very, I mean, obviously it's the n times n plus 1 over n minus 1 times n minus 2 times n minus 3 times s to the fourth, sigma x minus x bar to the fourth, and then some other junk too. Obviously, in statistics, some of the equations can get a little bit gross. So normally, even at the professional level, people make heavy use of libraries, and that's normal and expected. And you should not expect that all students are going to be able to go understand that stuff quickly. So ignore option one. Option two, just like we could get with the median, all you do is ask the frame for the kurtosis of the value that you want, just like with the mean or the median. It's descriptive statistics. So if you do that, can someone please tell me the kurtosis of the column that we have? I cannot grant cookies. We are not in person, but next year I might be able to grant cookies. What is the kurtosis of this column?
I'm confused as to what you're actually trying to ask us to do. Are we coding something here?
Yep.
Okay.
Okay.
All right.
What I'm asking, and I'll make it more clear in just a second. We've got this graph that I just shared screen again, and this is the one that I showed and messed with the screen reader too. That graph, I'm telling you, has a low kurtosis, but I'm saying, what does that mean numerically? We have to pin that to a number. Kurtosis is a numerical constraint. So what is the number? Let's have teach the system to calculate it by coding it, and then tell me what is the actual number for the kurtosis for that particular chart.
So we would write number.
What I would recommend is, you know that your data frame already has a selected column. After that selected column, and I won't show you the answer yet, I'm just trying to give you a hint. I would type frame and I'd press colon and I'd look for some kind of action related to kurtosis, just like you did with mean and median.
Oh. So the question is do we select a column or just not?
Yep, I'm trying to give you, to like kind of guide you to it. Obviously I'll show the answer in a minute, but I'm trying to get people comfortable kind of doing some exploring. This one's going to be a little bit exploratory.
You're scaffolding us.
Kind of, yeah. Oh, Mike Face has given an answer. Is it right? We'll see if others agree.
Hello, Johns.
Okay, I'll give everybody one more minute to try to solve it, and then I'll go through it. If you have solved it, or you think you've solved it, feel free to dump the number into Slack or Zoom or whatever. Into Slack. And if you're stuck, it's okay to say that too. It's not a problem. Okay, let's go through it. Now, if I'm going to delete the code that I wrote, and then I'll rewrite it. If I have a frame, I have this line of code that says add selected columns. Now, this add selected columns, it worked for the histogram, but it works for the kurtosis calls too. Basically, when you add a selected column, it's kind of like, it's very, oh, you know what? I know how I can describe this. It's very similar in a spreadsheet. I'm going to share screen on that. Adding a selected column is very similar to going into Excel and clicking clicking a column. That's the metaphor that we're kind of using for that, that stuff there. So this is dimensions.width. This is kind of like going into Excel and clicking column C and then telling it to do something with that column. It's kind of like saying, hey, column C, what's your kurtosis? That's really what we're kind of saying, or build me a histogram for that column. It's not visual, obviously, although we'll probably get to that point in Quorum Studio, but you get the idea. So in Quorum Studio, we've added the selected column, and we're going to then call the frame. We've got that column selected, and we're going to look for a value that is related to kurtosis. Kurtosis starts with a K. So even if we can't remember how to spell it, which is pretty normal for kurtosis, if we press K, it filters it down to two pieces. One is one that just says kurtosis, and one that says kurtosis selected columns. Kurtosis is only give me the first one that you have selected. And kurtosis selected column says, hey, look, I'm doing it on a bunch of them. Give them all to me, basically. So we're going to take the first one. We're going to rename the variable, although we don't have to. So number kurtosis equals frame : kurtosis. And then we're going to output kurtosis. And voila, the number is minus 1.469, which really what that means is that Mike Face gets a cookie as the first person to have solved that. Okay, now, that number minus 1.469 would be considered low. What number would a high kurtosis be? Okay, so here's the next exercise. We have about 20 minutes left. What I'd like you to do is to generate histograms for the other columns and see if you can't find one that has a high kurtosis. Think about it numerically and think about it through the chart. In other words, what we're going to do for the last part of this lesson, skew and kurtosis on their own are just academic concepts, but what you really use them for is data exploration. That's their purpose, right? They're there because they give us some clues about what's happening in our data set. So what I want you to do is just go through the columns one by one, generate the histogram for them, and then look at the skew and the kurtosis of that, and let's see what we can find. Let's kind of explore for a few minutes. So I'm going to give everybody about 5 minutes for this, and I'm going to do it myself too. And then I want to kind of pull up some that we might find interesting. Are people cool to do this task? The code is the same. You're just changing the selected columns. So you only have to change the one spot. So instead of dimensions.width, I'll tell you what, I'll do one just to make sure it's clear. The first column is dimensions.height. So if I run this exact same exercise with dimensions.height instead of dimensions.width, and I get the kurtosis, and I run it, I get this chart. And that has a kurtosis of minus 0.6. Higher kurtosis, but not very high. Low by any standard. So what I want you to do is go in and generate it for a bunch of the columns and see if you can't identify one that has high kurtosis.
But how do we know the column names? Like, where is that somewhere else?
Oh, it's in the spreadsheet, but I'll put them all in Slack just so that's out of convenience.
That's what I was struggling with. I was like, I know what I got to change. I just don't know where the list of things are without pulling up the CSV, which I obviously could have done, but I'm lazy. So
No, that's fine. Yeah, they only exist in the CSV. And the reason is because there's something you created yourself typically. Like a kid creates his own data set or her own data set or their own data set, I guess I should say. Yeah, I'll leave the screen up on the CSV for just a minute. And now don't forget, when you do this, as you go, if the data is not numerical, the histogram might do funny things. And it's okay. Like if it crashes or anything like that as you go, that's okay. Like that's normal. Like if you run your code and it says, oh my God, that doesn't work, that's part of learning. Right? That's normal in data science. But you can look at the data set and just explore around in it in Excel and kind of try to figure out what might be interesting. Okay, I'll give you another 4 minutes.
whoa, I found a big one.
Good.
This data is really strange though, because it's strange. The funniest thing is that we have subtitle age ranges of dog breeds in the code.
Yeah, I mentioned that to Hannah as we're going to put it on the list of things to fix. That's clearly a bug. That is not intentional.
Oh, that's just a typo or somebody
It's
copied.
a typo. Yeah, it's a typo. So you're clearly right though.
That's funny.
I agree. Okay, another 2 minutes. And while you're doing that, I'm going to cheat.
You're going to run on all of them, aren't you?
I certainly am.
What will it do though with the columns that would give you an error? Is it just going to say those columns don't work?
We're going to find out, because I don't remember. But that's part of the fun. Okay, 1 minute left. That seems like a pretty low kurtosis, Mike.
Yeah, but look at fuel information highway.
I refuse. All right. 30 seconds.
It says build successful, but then it doesn't run.
Story of my life.
Andy, is that about programming, about you? Build successful, but you don't run, or your programs don't run?
Sometimes I wonder.
Not successful, so that's a moot point.
What is it doing? All right, what have people found?
Well, the fuel information highway is pretty big. 172.96.
Fuel information, fuel type.
No, fuel information dot highway. Mile per gallon.
Okay, let's take a look at that one.
That's just going based off of the numbers. If I look at the actual data, it's probably stupid.
That's okay.
I mean, miles per gallon is going to be kind of narrowed anyway because vehicles have a limited capacity on how many miles per gallon they can actually get.
Okay. So if we pull up the fuel information, numerically, what is the kurtosis here? Visually, there's essentially, I don't know, 20, 30 bars. Actually, it marks 251 positions, but that's okay. But really, there's only 4 bars that are actually visually available. And the kurtosis is quite high. What is it?
1.72.9.
I actually get 172.
72.96, sorry.
Yeah. So that's really high. That's an extraordinarily high kurtosis. And you can see visually, at least, and you would see this with a screen reader too, by seeing all the blank spots, that what you really observe is that there's one really tall and skinny region, and that that everything else is basically blank. And that's sort of an indication of kurtosis right there. Okay. So what have we talked about? So this morning we talked about a couple of things: descriptive stats in terms of mean, median, and mode, and how you do those calculations. Why you might script it, which is as the data sets get larger, that can be an issue. In addition, we talked about how your data sets have properties, and those properties are things like skew and kurtosis. And those properties are useful because we use them in data science to make decisions. How do I analyze my data set? What is wrong with it? Things like that. So Skew and kurtosis are only one piece of the puzzle, but they're an important piece of the puzzle because they're used quite heavily in the field of data science. They're a good one to know. And so at this point, I think we've covered most of what I wanted to talk about for the first two sessions. Any questions, concerns, problems, complexity? Or are you mostly comfortable with this?
Mostly.
Tiffany, Sarah, Jill, Gina, are you terrified? Tim, Art?
Can you only run one at a time? Or
With the
how do you?
charts?
So I was just messing around, like seeing if I could just add to the chain to see if I could get more numbers at once but. then it
You
was like, no,
totally
you can't.
can. I didn't go over how to do it, but you totally can gather more than one at a time. In fact, you can even display all the histograms on your screen at once as well. You have to code it in a different way. And it's a little bit, I didn't go into it because it's kind of a pain in the butt, but like you can do it for sure. So, I mean, hypothetically, if you really wanted to, you could make all the histograms go on the screen and then you could have them battle each other. I mean, like you could do anything. It's a programming environment, so you could have it do literally anything in the universe. But there are easy ways to do stuff like that. It's just they involve some programming concepts we haven't really gotten to, so I've kind of avoided it. So
Okay.
arrays and stuff like that. And so we could go into it, but we kind of left it out. So, but yes, you can do that. So the trick is that add from selected columns version of kurtosis, and that's how you get them all. So,
Oh, okay.
yeah. Other questions, comments, concerns? I mean, is this cool? Is this lame? Give me some feedback here. So,
Well, for me, it's very interesting, and I'm just looking at the programming and just seeing some amazing things that can be done, because this is totally charts and graphs, yes, but just how it's done on this side of it is like, I'm just saying, oh, I'm not overwhelmed to the point of what am I doing? I'm just learning a whole lot of stuff to where I don't know what questions to ask because it's so new to me with programming.
that's a great comment, and I appreciate that, Tiffany. That makes a lot of sense. Yeah, so part of that, all that is at the end of the day, just engagement over time, right? Trust me, I think a lot of the people that have come to EPIQ for many years, the first year is always the hardest because it's like you look at this stuff and it's like I love what you said. It's not even sure what to ask, but that makes total sense. So thank you for sharing that. So, all right, okay. So we have another one at 10. So let's try to get maybe 10 minutes of break, just so that people can kind of like walk away for a few minutes and do whatever they need to do. So maybe let's come back at 10:05. People cool with that? Okay, so I'm going to stop the recording.